You ready to record? Are you recording? Oh my goodness, we're recording. All right. Whoa, I hate when it does this. It like goes out of control. Okay, 2.8. All right, let's join each other on this. First thing it tells us to do is to look back at the homework exercises from 2.3b. So I want you to turn your page back to 206, but keep your hand on the current page, 252. Yeah? That's cool? So I want you to go back to page 206, and I want you to look at all those problems on page 206. Okay? And then I actually want you to go forward a bit, and I want you to look at tonight's homework. And actually, I want you to look at the second page of homework, page 257, and look at all those problems. I want you to compare and contrast them. There is a singular stark difference between the problems on this page, 257, and on this page, 206, section 2.3b and section 2.8. Do you see the difference? What is it? Inequality signs, right? On page 206, everything has an equal sign, as we see up here on the board. And on page 257, everything does not have an equal sign. They have inequality signs. So go back to our first page here, our explanatory section here, 8. It says, what is the main difference? So go ahead and write that down, that in 2.3b, everything had an equal sign. And in this section 2.8, everything has an inequality sign. As you're writing that down, the next question says, what does inequality mean? What does inequality mean? Literally translated, what does inequality mean?
Not the same.
Not the same, not equal. Very good. Whenever we put the word in front of a word, it means not. We have inequality. It means not equal or not the same. Okay? And it's not equal signs, basically. We don't have equal signs. In this section, we're learning how to solve inequalities, right? Chapter 2's all been solved problems. Everything's had an equal sign. Now it's going to have an inequality sign. All equations. And so, first thing I want to do, let's go ahead and look at this. Which of the following is a solution to x is less than or equal to 5? Is 0 less than or equal to 5? Is 0 less than or equal to 5?
Yes.
Circle it. Is 5 less than or equal to 5?
Yes.
It is, because it's 4 equals it. So circle it. Is negative 1 less than or equal to 5?
Yes.
Yes, circle it. Is negative 5 less than or equal to 5? Yes, circle it. Is 7 3/8 less than or equal to 5?
No.
Put an X through that one. No, it's not. When we graph an inequality, I want to remind you of something interesting here. Let's look at this first one. X is more than negative 2. We're going to draw a number line, okay? And when you draw your number lines tonight, you know, it doesn't need to be rocket science here. We're going to have 1, 2, 3, 4, 5. I don't care how many numbers you put on this. You could put, you know, a couple of hashes on each side. You know, you just do 2 or 3, but you just got to have enough to cover the graph. X is more than negative 2, so we find negative 2, right? We find negative 2. Okay, and so one of the things we want to review here is this concept that when it is simply more than or less than, then we have an open dot. When we have the or equal to, we have to close the dot. So is this one going to be open or closed dot? Open dot. So we're going to find our negative 2. We're going to make an open dot on it. And then more than means we're going in this direction. We good with that? Yeah.
Where are you gonna find that? Like, what's like a, like, you know how we just word problems? Like, what's like a word problem that you could find something like this on?
We're going to do them all tonight. You're going to have answers tonight. Every answer is going to be like this.
I know, but those are just like questions. They're not like a word problem. You know, like
Oh, a word problem?
where would you like if you're working for somebody and they're like, would you find this somewhere? And
Is this a when am I going to use this in the real world question?
Yes.
Or is it just more of a curiosity, like?
Yeah, it's like curious. Like I'm just like asking like,
Well,
for
I
a
mean-
word problem. Like, are you gonna see things like this?
We are going to do word problems tomorrow
Yeah.
that are inequality word problems.
Okay.
Today we're going to start from the ground up.
That's what I was asking.
Yeah.
Okay.
Yeah. Okay. No, we're cool. It's good. Like I said, I'm low energy today. So don't take my straight face and lack of emotion as disappointment or frustration. I'm not. I'm in a lot of pain. I don't feel good. Thank you, YouTube. You now know that. Okay. All right. So let's do the next one. X is less than or equal to 4, right? X is less than or equal to 4. Again, we draw a number line, so each one of these, you guys are doing this with me right now. If it's not too good for me, it's not too good for you. Okay? So here's -4, here's 4. Again, if you just want to take it to those levels, that's fine. You want to write the rest of the hash marks, you can. So, 4. We find 4. Is it going to be open or closed dot? Closed, because of the or equal to. So this one we fill in the dot, right? And then less than means we're going in this direction. Agreed? All right. This next one, a little bit interesting. -2 less than x less than or equal to 3. Is that right? So we're going to draw a number line again. 0, 1, 2, 3, 4, 1, 2, 3, 4. Label them all, you can. If you don't want to label them, just leave them as hashes. We don't really care. Just want you to make it clear, okay? So on this portion of this inequality, closed or open dot? So we find the -2, this is an open dot. And then we find the 3, is this closed or open? Closed. We're going to have a closed dot there, and then we just connect them. And that's it. That's your answer. The values of x lie between 3 and -2, but they can equal -3, but they can't equal -2. The open dot means we are approaching -2, but we never touch it. That's why it's an open dot. Cool?
Yeah.
I want you to think about that for just a second, kind of a deep kind of a thing here. -1.8, is that close to that? Yeah?
Yeah.
And -1.9, is that close to that?
Yeah.
But here's the thing, well, how about -1.99? Is that closer?
Yeah.
A little bit. How about -1.999? And -1.999999999, right? And that's the reason why you have the open dot, is because people don't think about this sometimes, but infinity is not always that way. Sometimes it's that way. I mean, it goes deeper, 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 deeper. I mean, we just keep getting closer, 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 but we never quite touch -2. That's why we have the open dot concept, okay? So, as far as the real world is concerned, you know, graphing things on number lines just helps you visually see the graphical answer, right, to what you're doing. And the open and closed dot is a very visual representation of I don't quite arrive there, or I can't arrive directly on that answer. Okay? All right, let's turn the page. So how do we solve inequalities? Well, still use the 3-step process to solving. I need someone to read this big graph problem down at the bottom here to me. Somebody want to do that for me?
Yep.
Go ahead.
1 minus 2/3 y is greater than or equal to 9/5 minus y/5 plus 3/5.
Perfect. So, how do we solve this? Well, let's look up here. First thing, we treat it like an equal sign. We pretend there is not an inequality here, but an equal sign there. And we go ahead and we use the 3-step process to solving in all of its glory. We get rid of fractions, we distribute parentheses, we combine like terms, we get all of our x's to one side, and we apply the addition and multiplication principle. So let's go ahead and let's solve this problem. Do you have fractions?
Yes.
Yes.
What do you do with fractions?
Multiply it by the DCM.
So I heard get rid of them. I heard how do we get rid of them? We multiply by the LCM. So the LCD or LCM is what? What is it with 3 and 5?
15.
It's 15. And if you don't know that, we have 3, we have 5. What's the prime factorization of a prime number?
It's nothing.
It's itself, right? Prime factorization of 3 is 3. Prime factorization of 5 is 5. How many times does 3 appear here?
Once.
How about here?
Once.
Well, here is 0. So we count it once. How many times does 3 appear here? Once. Here, 0. How many times does 5 appear here?
Once.
And here? So we count it once, we multiply, and we get 15, right? So if you have 2 prime numbers, you can just multiply them in any instance, okay, and get the LCD. You're going to multiply everything by the LCD. Okay? So we're going to take 15 and multiply it times this side, and 15 and multiply it times this side, which means this has to go to here and to here, and this has to go to here, here, and here. We've done this before. We know what we're doing. So I'm not going to uncork the pen 5 times. I'm just going to write 15 there 5 times for every term that's up there. And I'm going to have 15 times 1 minus 15 times 2 thirds y more than or equal to 15 times 9 fifths minus 15 times y over 5 plus 15 times 3 fifths. Where did I get my minuses and plus from? From all of the minuses and pluses up here, right? Help me. Help me out. 15 times 1? 15. Minus, can I cross cancel the 15 and the 3?
Yes.
Yeah? What do they become? Become 5. So I have minus 5 times 2y, which makes what?
10.
Negative or minus 10y. More than or equal to 15 and 5. Do they cross cancel?
Yeah.
What do they make?
3.
3. 3 times 9 is? 27. Okay. Minus, can I cross cancel here?
Yes.
15 over 5 makes?
3.
So I have minus 3y. Plus, do the 15 and 5 cross cancel there?
Yeah.
Yeah, and they make?
3.
And 3 times 3 is 9. Does this look easier than the original problem?
Yes.
For sure. I have taken care of fractions. I've taken care of parentheses. Do I have like terms on this side? No. How about this side? 27 and 9 make what?
36.
So 15 minus 10y is more than or equal to 36 minus 3y. I need to get all my y's to one side. You guys okay with that?
Yep.
Okay. There's 2 ways to do it. What do you guys want to do? You guys want to add 3y, you say, or what do you want to do?
Yeah.
Okay, let's add 3y. Watch this. I add 3y and I add 3y. And I'm going to get 15 minus 7y is more than or equal to 36. These cancel. Agreed? I'm going to subtract 15 and subtract 15. And I get negative 7y is more than or equal to 21. And I'm going to divide by negative 7 and divide by negative 7. And I get y is more than or equal to negative 3. Now before you say anything to me, I want you to come back here. What was another way we could do this problem? Instead of adding 3y, we could have added 10y. Okay, so let's do that. Let's add 10y. Let's add 10y. Okay. And these cancel, and I get 15 is more than or equal to 36 plus 7y. I subtract 36 from each side. I get negative 21 is more than or equal to 7y, and I divide by 7 and divide by 7. And I get negative 3 is more than or equal to y. Please look at these two answers. Look at them closely. Are they the same? Y is on the less than side. Y is on the
Greater than.
so they are not the same. What is a way to express this inequality, give it the same meaning, but show it differently? What would you write? Y is less than or equal to negative 3. Are those the same? Yeah, those are the same, but these are not the same as this answer. So which one is correct? Left or right? Well, here's the deal. You remember when, look up here, you remember when we solved these and we had an equal sign? It didn't matter what we did. As long as we obeyed the balance rule, the answers were the same. And so if I have, look up here, if I have y equals 3, does it matter if I write 3 equals y? No, because an equal sign is identical on its left and its right side. But if I have, y is more than 3, I can't just simply say, I can't just, change this up and say, 3 is more than y. Those are not the same, right? The 3 and the y can change sides with an equal sign, but they change sides with an inequality sign. Y is on the more than, y is on the less than. These are different. Agreed? So I have to address this. And as mathematicians began to solve inequalities, they realized a problem was created by the nature of the inequality sign. That you could use the 3-step process to solving, but you needed to address this, kind of which side is the y on, and so we have a second step here, and this is the step. With one exception, so look up here, we treat this like an equal sign with one exception, and the exception is in the multiplication principle, we need at times to use the flip principle. Well, what is the flip principle? Well, here it is. In and only in the multiplication principle. So let's look at this problem up here real quick. Was this step the multiplication principle? Nope, this step was fractions. Was this step the multiplication principle? Nope, this step was distribute parentheses. Was this step? Nope, this was combine like terms. Was this step? Nope, this was get all your x's to one side. Was this step right here? Nope, this is the addition principle right here. So the only time that we are addressing, so this is, all right, this is the one side right here, sorry, one side was right here. This is the addition principle right here when we subtract 36. So right here, when we subtracted or divided both sides by 7, this is the multiplication principle. So all this other stuff here, we can use the three-step process to solving, and we don't need to think or worry about anything. We can treat it like an equal sign. But when we get to the multiplication principle, let's look up here, in and only in the multiplication principle, when and only when I multiply or divide both sides by a negative number, okay, I flip the inequality sign. Did you multiply or divide both sides by a negative number here? You did?
No.
Is this positive or negative? So, is this answer correct?
Yes.
Yeah, this is the correct answer. This is the correct answer right here. And you could rewrite it this way because these are because y is on the less than in both of these. Agreed?
Agreed.
Is this the correct answer here? Well, let's look. We already took care of fractions and parentheses, like terms, so we got to here, and this is when we dealt with one side, getting all of our variables to one side. That's this right here. Understood? And this is the addition principle right here where we subtracted 15. So this is the multiplication principle right here. Did we multiply or divide both sides by a negative number?
Yes.
And when we do that, we have to flip this sign. Now are these the same answer?
Yes.
Most assuredly they are. And so that is the flip principle. And that is the one new thing you have to apply when solving inequalities. When do we do it? Only in the multiplication principle. Only when we divide or multiply both sides by a negative number. Then you have to flip that sign. Cool?
Cool.
Let's go to the next page. So you should have all this written down on that one example there. Okay. Do you guys want to get into groups or do you want to work on your own? Raise your hand if you want solitary. Raise your hand if you want groups. All right, groups win today. Quickly review these. The first problem up there, 18 minus 6y minus 4y. 18 minus 6y minus 4y. Less than 63 plus 5y. Less than 63 plus 5y. We were asked to do this two ways. This is going to end up being like terms here. 18 minus 10y less than 63 plus 5y. Over here, we're going to do the exact same thing. But we now need to get our y's alone. I want you to get the y's on the left here. So we were to subtract 5y. We ended up with 18 minus 15y less than 63. We apply the addition principle. We subtract 18 from each side. That is a negative to both sides, but do I flip it now? No, because this is the addition principle. Negative 15y is less than positive 45. I need to divide each side by what?
Negative 15.
Negative 15. Because I divide each side by a negative number, I do what?
Flip that boy.
I flip this. So this is y is more than negative 3. Say woo if you got it right. Good. Okay. Over here, we wanted to add 10y to each side, and we get 18 is less than 63 plus 15y. We subtract 63 from each side. Our calculator reveals that's negative 45 is less than 15y. Divide by 15, divide by 15. Did I divide both sides by a negative number?
No.
No, so it stays. I don't flip the sign. This is negative 3 is less than y. Are these two answers the same?
Yes.
They are, because y is on the more than side, y is on the more than side, right? So we asked you up there, are they the same? Well, if you followed this correctly, they should be the same, okay? Okay, these other little problems up here, I'm going to erase this. You guys cool if I erase this?
Yep.
Yeah. Okay. These other little problems up here, they're just to make sure that you are solid in your knowledge of the flipped principle, okay? So this first one here is negative 3x is less than 18, okay? And what do we have to do to get x alone? Divide by negative 3. Okay, divide by negative 3. We definitely have to flip that, right? Because we divided both sides by a negative number. Agreed? It's going to be x is more than what? Negative 6. Very good. Our next one is negative 3x less than negative 18. Okay? This one sometimes catches a few people. We have to divide each side by a negative number. We should flip it. But now then they'll say, well, that made both those positive, so do I have to flip it? It doesn't matter what it makes it. What matters is what you're doing to it. And you are doing a negative to both sides through multiplication or division. Therefore, you have to flip it. It becomes x is more than positive 6. Say woo if you got it right. Good. Okay, so the principle there was it doesn't matter if the negatives cancel each other out. You still have to flip it because what you did to both sides was divided by a negative number. 3x is less than negative 18. Here we divide by 3 and divide by 3. Again, did we divide both sides by a negative? No, we did not. So the sign is staying the same. Sometimes students say, well, that's a negative answer. It doesn't matter what the answer is. Again, it matters what you do to it. This is just x is less than negative 6. Tell me, woo, if you got it right. Good. X plus 3 is less than 18. X plus 3 is less than 18. Okay, this one here, we were subtracting 3 from each side. So students say, oh yeah, I did a negative to both sides. Do you flip it? No, because this is not the multiplication principle. It's the addition principle. It doesn't matter if you subtract both sides. It only flips if you multiply or divide both sides. This cancels. X is less than 15. Say woo if you got it right. Good. And the last one, negative 2/3 x is less than 6. Negative 2/3 x is less than 6. Who's sharing sides with x? Negative 2/3 is being multiplied, so you're going to divide. So ultimately, you have to take negative 2/3 and divide it by negative 2/3, which is going to be less than 6 divided by negative 2/3. These two will become negative 2/3, change division to multiplication, flip the second fraction. This is an x here, my bad. And these cancel. And so x is alone. You have x is less than 6. Change division to multiplication, and 3 over negative 2. This cancels, becomes a 3. That's a negative. And so it ends up being x is more than negative 9. Had to flip it because we divided both sides by a negative number. Say woo if you got it right. Okay. All right, guys. Yes.
So I know we're like out of time, but
Oh, we're good.
so our group, I'm pretty sure we like multiplied by 3 to like get rid of the fraction. Is that
Yeah.
still good?
Just the same.
So
Okay,
look at this. If you took negative 2/3 x is less than 6, and you said, hey, I want to get rid of fractions, Brother Rich. I want to multiply both sides by 3. These cancel. You end up with negative 2x is less than 18. You still had to divide by a negative 2. When you did that, you had to flip the sign. X becomes more than negative 9. You could have done it that way too. It doesn't matter as long as you got the answer right. Did that answer your question? Yes, it did?
Yes,
Okay.
thank you.
Hey, listen up. So, tomorrow we meet, right? And so this homework assignment is pretty straightforward, okay? Shouldn't be too bad. I had some students that within 10 minutes, they were, like 2/3 the way done with this assignment, okay? So, you guys can rock through this. Have a good one. I'll see you tomorrow.